It might have been more appropriate to title this video, How Do We Disagree? I mean, asking why seems a little arbitrary. How would be more to ask about the ins and outs and the steps involved with disagreement, which will definitely be mentioned in the video. Whereas with why, would I be talking about some psychological urge to refute someone's point? Or maybe it's to spread our beliefs to others, either as a way for social acceptance or to pass down our ideas for some grand legacy. Either way, our why seems to grapple with a dual meaning. On one hand, why asks from which cause disagreement occurs, but on the other, why asks for what effect or purpose disagreement serves. Which might get a little hairy. But I think understanding both disagreements' causes and effects necessarily entails first understanding how we go about thinking and ultimately disagreeing, and then the greater essence might become clear, that being the why. So let's get into the how, because I find it kind of weird that two people can live on the same planet and get completely different ideas about it. And no, I'm not just talking about if pineapples are pizza toppings. Might be the same planet, but you and I, different tongues. But what about brains? Do you and I process information differently? And more importantly, how can we know whose processed information is correct? Well, since we can't fully reach inside there and look around, it helps to be able to give some reasoning that supports and potentially explains our processed information. Like if we can show our work, maybe you can tell if my brain does what your brain does. Luckily, there are three primary ways that we show our mental work. Three types of reasonings to get from reasons, otherwise called assumptions, observations, or evidence, to that juicy process information, which might be the topic of a disagreement, usually called a conclusion, assertion, or a thesis. And with these and those, we can get rock solid proof which brains think right and which think wrong. Okay, so first, what most people refer to as logic is usually deductive reasoning. Sherlock Holmes famously uses this type, as they are both known for their vigorous processes, which lead to an unquestioned consistency and accuracy in their results. But that's only because he's a fictional character. It would probably be best to refer to his conclusions as dirty little abductive ones instead. But deduction is known to be concrete and always true, with the help of all these fun little rules that you have to follow to a T. We'll make this part quick because rules are pretty lame. Okay, rule number one, this is the big boss, it's called a conditional. It has the format of if, then, and it looks like a big arrow. The big arrow is like cause and effect. If your causes are present, then you get the effect. For example, if this video is good, then subscribe. This conditional implies that people subscribe when videos are good, which is pretty intuitive. This means that it is logically impossible for the video to be good and for people not to subscribe. Or that the conditional is wrong, but we don't talk about that. The conditional is fun and is the best deductive rule because it shares its structure with formal logic as a whole. The format for logic is usually that you assert a couple assumptions to be true, throw some rules at it, and out pops a conclusion. So it's just like a really big conditional. If these happen, then this happens. With the full logic version though, you have to explain your process with all these dumb rules. In total, there are like 10 main ones and a bunch of weird guys too, but contrary to the chart of hieroglyphics, they're all actually super simple. Each one individually is so fundamental to our brains that virtually anyone can use them and understand them. Let me try to break down the one that, in my opinion, is the hardest of them, De Morgan's Law.
Hey, I'm from the future. Okay, so first the symbols. The droopy minus means not, the little v means or, and the caret means and. The amputated plus means therefore. It's just a logical equal sign basically. So let's use real things for our variables. We have P for pepper and Q for salt. Now we read this as we don't have either of pepper or salt. Therefore we don't have pepper and we don't have salt. It's really quite simple. Not having either means not having each one respectively. The rules themselves are very straightforward, as is logic, but the assumptions, well, I'll let the other guy get to that.
Everyone uses this stuff all the time, just like really quick in our heads. And this is literally all the rules to logic there are. Like, this is what being logical is like. It's kind of silly because you don't need a lot to be proficient at it, but I think there's a pretty common perception that lots of people don't think logically, but logic comes with the hardware. Bringing us back to the question of why, it won't be too often that two people start in the same place and deductively find disagreeing conclusions. So if a lapse in logical development is not the root of disagreement, then what is? Well, let's talk about abductive reasoning. This one is much simpler. You just take some observation like puddle, and then make a guess that it recently rained, or someone spilled their water, or someone's been crying. All would be fair abductive conclusions, even though some might be better than others. That's why it's the straw house of reasoning and can be especially toxic if you just take one example and make a random guess from it. This is why Sherlock Holmes is so compelling. The guy makes all these independent observations about a situation and makes some super educated guess that turns out to be true. Abductive reasoning is supposed to be about finding the best possible explanation for something, and it makes total sense if you correctly found the best possible explanation, like in Sherlock's case, but it often leads to unreliable generalizations if you're non-fictional. Using an anecdote, for instance, follows the same format of having a specific observation that upholds some conclusion, but the conclusion has no claim for specifically causality. With your anecdote, the conclusion can be found, but that's different from the conclusion being deserved. The reason why this logic works is because the conclusion accounts for the observation, and that it's much easier to spot spotty reasoning when there's a transparent contradiction in claims. But in this case, we utilize the unknowns in a compelling argument to kind of squint our eyes and pretend the math adds up. Ah, bit of cash! Now this must be why we disagree. Those pine cones who argue this way are to blame. You, on the other hand, you utilize facts of the cold and hard variety. But a moment, I implore you. For we still have one form left, and it might just be the most dangerous one of them all. Cue inductive reasoning. It is similar but more stable than abductive reasoning, because instead of using just one observation, it uses a bunch of them. It collects a set of specific observations that all point to the same thing, the conclusion. More connections, more stability, and reliability. This is the reasoning used in scientific study because it's a synonym with finding statistical correlations. This one can also be unreliable, but has scaling consistency related to the number of observations, perceptions, or independent data points that you have. The conclusion that someone works on a Saturday because they just worked 5 days in a row is a pretty bad bet to make, but the conclusion that someone works on a Saturday because they just worked 621 days in a row is not as fallible. The reason why has to do with probability and is more Bayes' problem than ours, but scientists usually have that figured out enough to get pretty good accuracy in their conclusions. But what happens when the conclusion comes first? Imagine that you believe that sobriety is bad. It gets 2 thumbs up from me, but you're going to need some reasoning to back it up. You take your conclusion and you find some nugget of evidence to support yourself. You do some digging and find a study that shows higher rates of hospitalizations for sober people when compared to mild drinkers. Well, there's all the proof you need. If the study is accurate, then sobriety is evidently dangerous. Well, let's get into it. First, start with the references. What are the people saying about it? Looks like it's getting some good buzz, so we're all set there. Now let's examine the publishers and contributors. It looks like the Department of Epidemiology and Prevention of Italian Letters, Neuromed, is in cahoots with the Department of Nutrition of the Harvard T.H. Chan School of Public Health. Harvard? Sounds good to me. Publisher Wiley, they're on the New York Stock Exchange, and Wikipedia does not note any fraudulent studies in the controversies section. Even this, Wiley, established publisher, seems good to me. What about biases? Only mine for Italians, that's a check. Sample size, 21,000, check. Median follow-up time, 6.3 years. That's a check. The study is secure. So our study is good and it supports our argument. So why might it still fall flat? Well, because we have a specific finding and get a generalized conclusion. The trick here is you can pull a correlation from the study that shows more hospitalization in sober groups when compared to the 1 drink per day group. But if you are looking only to affirm your conclusion and ignore the data set as a whole. This process is pretty damning because this is exactly what abductive reasoning is. But this time, it's a wolf in sheep's clothing. What the study actually shows, if you don't begin with anything to prove, is the same thing that the smart guys who wrote it found. Quote, you wanted me to read it for you? Yeah. So moderate alcohol is complex, but a lot of alcohol is much worse. Notice that their findings make no judgment on moderate alcohol use because the study is objective and judgments are inherently subjective. The emerging problem here is science feels good when it's the basis for an argument. You endow yourself with the power of the mighty fact, but you must wield it responsibly. Because when you have something to prove, often you just kind of force the fact to do what you want and can use it for evil. For more examples of how statistics and research can be manipulated, I found Zach Starr covers the topic much more in depth, a video which I'll link in the description. By this point, most people are wisened up to the idea that the lion's share of reasoning is a result of some preconceived notion or bias that is lazily supported after the fact. People don't have the time or qualifications to do an advanced clinical study or a weird drawn out proof of assumptions to conclusions. And as we've seen, even if we acquire such information, our conclusions may not be better for it, since any good reasoning can easily be corrupted by leaps in understanding. We subconsciously do these logistical acrobatics all the time and end up validating our opinions with super shaky premises. In life, we routinely only have one data point to make our conclusions, that being our own experience. One laser-specific perception of reality. And as a result, we often feel forced to make assumptuous conclusions with an extremely limited set of observations. What abduction and induction with their fallibility and their differences show is that perception makes a huge difference in the reliability of conclusions. The more observations, the more data points, the more accurate the conclusion, and in turn, the more accurate your perception becomes. Looking back to Holmes, it is not the conclusion from his perceptions that are so profound, but the fact that he can accumulate these true perceptions in the first place. In reality, it is a girth of perceptions that give you the best shot at truth. Maybe it is the role of disagreement not to assert your perceptions as truth, but to exchange perceptions to get closer towards truth. The main point of this video is really to stress that it's not about being logical or who has the most statistical evidence. It's more a matter of understanding that all conclusions inherently come from guesses about reality, and the more we understand each other, the less guesswork is required. So perceive others and disagree less. Okay, thanks. Bye.